Well, hey, and welcome back to Blockchain, Cryptocurrency, and Web3 Foundations, Module 4, Blockchain Use and Abuse. So as per usual, I'll ask you to take some notes while we're going through slides this module, and specifically writing down what questions might come up for you, terms you don't recognize, and what content might be confusing or missing. And we'll use that in this week's discussions. Okay, so far we've gone through a lot of interesting use cases for what blockchain might be able to do. I've seen that in the class discussions. But I think it's important for us to kind of take a step back and think about blockchain really in a lot of cases might not be the best solution. So dreaming about things that work really well, we should also be critical about what those things really should be doing. Because it really does do some really awesome stuff to drive us towards these robust decentralized systems that I think are really exciting for all of us. And I think that's not just for technology, but it could also be for society if we do things right. But we do need to be really thinking critically about this stuff. So we need to consider, do we really need a blockchain? Because if you don't need a tool, there might be something better out there that you should be considering, right? So a lot of blockchain projects, especially earlier in the days when people are just starting to learn this stuff, is we're looking for a solution in search of a problem. We've got blockchain. What do we apply it to make sure that it works, right? It's really best to go from the problem that you want to solve and then investigate if blockchain might be the right thing to use. This is true for any real technology, right? Blockchain really is almost assuredly not the best solution if you're looking for simply data redundancy. There is plenty of other things out there that help you with this. Distributed storage and access to whatever this data might be or services that you have. Blockchain really does some of this, but it is not the only tool, and it is a very blunt object and does very specific things if that's all you're really after. General security and especially privacy, this blockchain is not this. We'll go over into this a little bit more into this presentation. And if you're looking for simply a bridge to do business to business or business to consumer systems where you can have intercommunications, a lot of people are thinking about these kind of applications where blockchain is, again, a very blunt object. It's not very good for this. And one thing to be critically considering, if you're using especially a public blockchain, if you rely on a provider for your infrastructure, then really there's some caveats that might undermine the entire use case that you're trying to go after with trusting the blockchain as opposed to a provider for your infrastructure to access this blockchain. So we'll get into that more. So the other thing that we really need to consider is that blockchain being a massive distributed network is, especially things like proof of work that we've already discovered, it is very, very expensive to use. So if you're using this computational resource of these thousands or millions of computers, right, it versus using something that you could do on a single machine or off-chain, you probably should. So a truly smart contract, as we were talking about last week, is something that will be optimized to do everything possible off of the resources of this network and only do exactly what is needed on the chain itself, right? And the other thing to consider here is that bugs with this, especially in cryptocurrency, may result in massive losses. One great example earlier in the days of Ethereum was the DAO hack. There's a link in the slides if you're interested here, where about 3.6 million ETH was stolen. And that at the time was about $250 million. And today, you might be able to figure out what that is. This was due to simply programming error, right? And it's very unfortunate, led to some very fundamental changes in how the network worked to try and mitigate this, right? But if you're doing things wrong, in especially cryptocurrency land, you can make things like assets accidentally go to an address that no one can access for the rest of time. So if you're writing contracts incorrectly or using the system incorrectly, it simply just user error can cause major things to happen that are really bad for you. And there are so many more threats that can exist from doing this stuff. So if you're going to use blockchain and you're going to use smart contracts, you really need to make sure that you're evaluating and auditing the use of those so that you don't run into these kind of errors. And blockchain is most definitely not cheap, right? It directly scales with the costs that you're using there, right? So one great example, we read, I believe, last module with the white paper for Ethereum, Vitalik Buterin. This guy, he said this is about a year ago, I believe. Ethereum is about 1 million times less efficient for storage, network, and computation. And it's about 1 million times slower as well. So if you're thinking about using a cloud provider for a distributed data store, potentially an immutable data store, there's offerings for these that don't use blockchain, then if it's a centralized provider that is just fine to use for you, it's probably going to be a lot more efficient to use that, a lot more efficient. So something to consider. Methods to optimize, really here again, you want to opt for the minimum viable stuff that you can put on chain. I want to drive that into everyone's heads as much as we can, is that the blockchain, yes, it is a database, but really what it is a verification engine, and it is a source of arbitration resolution, right? So when you really need to make sure that the data is going on is just succinct enough to tell everyone what the truth is in the situation, so we all can look back on it and agree that that's what we settled on, right? So things like off-chain storage for any of the data that you need to associate with that is really critical to consider. Things like sidechains and other scaling solutions that you might have wandered across in your research can really help a lot with this, and various other tooling that we'll get a little bit further into this course. And then really a lot of people, especially who are not familiar with cybersecurity deeply, and I fall into that boat at least somewhat, is blockchain is most definitely not a broad spectrum security solution, right? It distributes risk and makes attacks much more costly. As we've talked about, the incentives and game theory around consensus for this data, those can be very robust in a public setting, but it does not do anything for access and firewall controls. In fact, quite the opposite most of the time. In a public setting, almost everything is completely transparent and auditable and viewable by everyone. So if there's something you want to keep private, or something you want to guard access to, putting it on a public blockchain is probably a very poor decision. So the network's ledger also may be very robust, right? So this blockchain might be immutable and trustless and transparent. But what about your node that you're running the software on and you're communicating directly with to try and judge what the rest of the network is doing, right? So cybersecurity of your node in particular is of critical importance, because if someone can come in and hack into your computer and fool you into thinking you're connecting to the network, but you're actually connecting to something incorrect, or it's corrupted your database and your systems that you're using, then it undermines the entire system. So there's plenty of times in which this kind of stuff has happened out in the wild, again, in the cryptocurrency example with exchange hacks. So there's a link here, you can look around this, but very many times when substantial losses of funds occur, it's because not the blockchain had any issues itself, right? The ledger is fine, but the keys were compromised for these servers. So we really need to take that into account, is that the systems you're using need to be absolutely secure and robust in a traditional cybersecurity way with those firewalls and access controls. And then really, if you do have this infrastructure, is who is owning and operating and securing these nodes on your behalf if it's not you, right? Do you trust them? Because as you'll see in the cryptocurrency world, there's an expression, not your keys, not your coins. And really, if you don't have direct control of your keys, then you don't necessarily, then you implicitly are trusting someone else to use these on your behalf. So exchanges, centralized exchanges really are the most critical example of this. But as we move further into what blockchains can do, things like OAuth providers effectively here, where we're using keys to prove who you are, that you say you are, if someone else manages these on your behalf, they can impersonate you, right? So if you don't actually secure this stuff on your own independently, then you do have to implicitly trust someone to do it on your behalf. So these cloud or blockchain as a service providers, as we'll get into, may be able to do all kinds of things to track, to censor you from accessing the network, or revoke your access, or take your funds, all kinds of things. So in cryptocurrency, this is very important. In blockchains at large, this is very important. So all of that said, all these things you need to really consider. Maybe you do really want blockchain and that you're not searching for a problem. You actually do have a problem where blockchain could be a good fit. You might want to use it, but do your users, right? So if you've designed something for more than just yourself, presumably, because this is a distributed network we'd like to have peer-to-peer connections on, you got to have all the parties who are using it understand, as we've already found out, that applied cryptography applications are really kind of cumbersome. As Keybase, for instance, is an example. It's really cool what it can do, but it's confusing and it requires some learning, right? And the idea of managing your own keys and understanding what they are and how to use them and how to secure them, that is a big ask, right? And I think we'll get there as a culture in our society as it becomes more prevalent, but we sure aren't there yet. So if you're going to use this stuff, you make sure that your users are also able to do this, right? Or help them understand how to do this, right? And blockchain really might not be the best fit, but it most definitely helps. And I think this is probably one of the most important parts, is that the standards in which we communicate. Blockchain, it might not be the best solution, but it absolutely can help be a forcing function to make us all use the same system and talk the same language. That is a very powerful tool when we're moving forward. So even if blockchain is kind of an obtuse fit, the forcing function of those standards really can be very powerful, but it's not required. And business-to-business databases. So if I want to trust a business partner somewhat, right? But we also want to make sure that there isn't any funny business happening in our books, especially if we have multiple people interacting with a database that's, for instance, supply chain tracking between both of our parties, right? And doing things like accounting internally, in-house, just between these two businesses. It might be an interesting private and permissioned blockchain solution, but there's a lot of caveats to that. And do you need that much overhead and infrastructure? And if you're really just running a blockchain on a machine that you both have access to, is it any better than just having a secured access typical database? Something to deeply consider. Right? Some reasonable use cases of blockchain, one example that comes to mind is potentially outsourcing user credentials, especially in the world of GDPR that we live in now, and increasingly the demands of the users to have more control over which data that their providers have access to. Outsourcing the ability to interact with your data and interact with your user profile to the user themselves might be really a good thing using key management systems like we've talked about now. So if you can empower your users to have the keys to give all the access, then you're giving them the responsibility to take control of this stuff, which is a pro and a con, right? And then, especially in cryptocurrency, if the value then is the responsibility of the user, the liability that you have as a business is much, much lower. So this is, again, it's a pro and a con. You can help them or potentially reduce your liability and empower them, right? So that might be something to consider. And so user managed stuff in general and blockchain, I think, is something that we'll have to grapple with what are the best practices in the industry. I don't think there's a great standard yet, but something to consider that it's a reasonable use case for blockchain. So getting more positive is like maybe actually blockchain is a very positive fit. Right? I think that what we see in public permissionless blockchains is censorship resistance is really, really high. So for instance, if I'd like to send a transaction on Bitcoin or Ethereum, there is very small chance that once I publish a transaction that someone's going to be able to stop this. Very, very small, diminishingly small. And if you have a sense of what the network is doing and how to interact with this, for instance, running your own node, the chances effectively approach zero. It's very hard to censor people, as well as transparency. So if it's really important in your application that publicly auditable data should be out there and make sure that anyone can see it, for instance, whistleblowing and things like this, blockchain might be a really good use for this kind of stuff. So on those same lines, mission critical public data. So for instance, reports of the public audit of the books for the city, for instance, right? This might be really good place for this, right? Or for instance, public records that come from judicial proceedings, right? Voting records, things that you want to be absolutely public. Then maybe this is a great use case for it. So let's look at some more. Potentially, if you need to have mission critical data out there, something like this public data, instead of putting everything on chain necessarily, having this fingerprinting system that we've talked about with hashing, right? And storing some of this off network, but using it just to have the proof of the original data as uncorrupted could be a really great place to use this. It's a very common industry practice. And of course, as we talked about, smart contracts and dApps. If you're dealing with money, then this can be a great use for blockchain to make sure that the system works as expected and no one can revoke on the terms and conditions that we already locked ourselves into, right? And one term I really like that's kind of lingo of the industry here is unstoppable, for better or worse, business logic or code, right? So you really can't, once we lock into an agreement, revoke this unless it's in the contract that we put together, right? And of course, cryptocurrency integrations make this all the more powerful because we can program the money to do what we'd like. And then everywhere and anywhere that we can pull out the middleman of our system, right, is reducing the reliance on a third party, especially when it's an extractive in terms of monetary resources, third party, right, between interacting peer to peer. This blockchain can really help with this if it's used with all of these caveats that we've discussed in mind, right? And then I think one of the most interesting aspects of blockchain that you can kind of consider and ponder on is that out of all the systems out there in the world, I think that this is the first time that we can have provable digital scarcity. And this is abundantly, apparently, very valuable and desired in the NFT land that we're in right now. It is a unique object out there in the world, and seems to be a very valuable thing that people would like to have access to. And as well as in Bitcoin, for instance, this 21 million supply is fundamental to what makes it valuable, right? And then thinking a little bit further is if we can have a robust system of oracles, as I think we've mentioned before, mapping this digital scarcity into real world objects that are scarce in their nature can have profound effects in how we deal with ownership and assign all kinds of things. And finally, public data security. So thinking about what kind of information you need to be public in some way, potentially aspects of your identity, for instance, right? If you need that to be absolutely secure but publicly accessible, blockchain can help with this kind of stuff. And there are so many different things, and we've already been discussing here in the class discussions, and I hope we can continue that. There's really some solid use cases, but we need to be very, very critical when we're thinking about how to implement these use cases within whatever logic we'd like to. And I think with that, that's it. There really are so many applications that could be used, but there are also plenty of applications that are just hype. All right, they are not very good, and we need to be able to identify those quickly and to try and make robust arguments as to why those are not very good use cases. And I encourage you to take a look in the discussions this week where we'll dive into a little bit deeper. In next module, we're really going to look at some more formal ways to assess what applications are valid, more than kind of the soft metrics that we have here. We can put some objective metrics in and discover if there really should be a solution put in place with blockchain or not. So with that, thank you guys.